Hello viewers, welcome to the concrete laboratory for performing the fineness test of cement by Indian standard 90 micron sieve and Blaine's air permeability apparatus. But before we proceed further, let us recall that development of strength of cement depends upon its reaction with water. Finer the cement, larger will be the surface area per unit volume. For example, in this case, the surface area of one cement particle of size as shown shall be equal to 24 centimeters square. If the same cement particle is broken into number of smaller cubes, then total surface area shall become 48 centimeters square. Greater surface area of cement particles will result in better contact with water and hence effective reaction. This reaction results into development of cement strength. The degree of fineness of cement can be measured in two ways. The first and the convenient method is sieving through Indian standard 90 micron sieve. And the second method is measuring air permeability by Blaine's apparatus. To start with, let us perform the fineness test of cement by Indian standard 90 micron sieve. For this, measure 200 grams of cement sample. And place it on the 90 micron sieve with pan fitted at the bottom. Now place the lid at the top and give gentle shaking for 15 minutes. The motion of the sieve should be clockwise, anti-clockwise, forward and backward. The retained weight indicates particle size larger than 90 microns. Now weigh the residue left after 15 minutes of shaking and determine the percentage weight retained. For example, in this case, the weight retained is 16 grams. Therefore, percentage weight retained shall be equal to 16 divided by 200 multiplied by 100 is equal to 8%. The percent residue should not exceed the specified limits of IS code. For Portland cement, the specified limit is 10%, whereas for rapid hardening cement, this limit is 5%. A more scientific and accurate method of determining the fineness of cement is by Blaine's air permeability apparatus. In order to understand the procedure to perform the experiment, let us first identify the various parts of Blaine's apparatus. Permeability cell forms the most important component of the Blaine's apparatus in measurement of fineness of cement. The cell has 12.5 plus minus 1 mm diameter and 50 plus minus 1.5 mm height with a plunger at top. The bottom portion of the cell comprises of conical shaped ledge which connects the cell to a U-tube manometer through a rubber coupling. The junction of the cylindrical and conical ledge portion of the cell sports a perforated metal disc having 1 mm perforations. Filter paper disc of number 40 Wattman is used in conjunction with perforated metal disc in the cell. U-tube manometer has one arm provided with a stopcock and a pressure bulb through a rubber tubing. This pressure bulb is used to create differential air pressure in the two arms. The other end of the manometer is open to atmospheric pressure. After having explained the various parts of Blaine's apparatus in detail, let us now perform the experiment. To start the experiment, while the interior surfaces of the permeability cell Now place the perforated metal disc in position and lower it down with the help of a steel rod so that it rests on the ledge portion. Now place a filter paper disc on top and again lower it down to cover the perforated metal disc plate. Now weigh calculated quantity of cement say 2.8 grams and place it in the cell. Insert the plunger and compress until the plunger collar comes in contact with the top of the cell to ensure the required volume and hence the porosity. Now connect the permeability cell to the U-tube manometer through a rubber coupling. Open the stopcock and press the pressure bulb till the liquid in the manometer is depressed. Close the stopcock when the liquid level is at the bottommost mark AA. When the liquid level just touches the second mark BB, start the stopwatch. Stop the stopwatch when the liquid just touches the mark CC and note the time T in seconds. In order to calculate the specific surface area of cement, we shall use the equation S is equal to K under the root T, where the constant K in the present case is 486. Putting the value of time T in seconds in the above equation, which is 36 seconds in the present case, the measured specific surface area shall then be equal to 486 multiplied by 36 under the root, which is equal to 2916 centimeter square per gram. Minimum of 3 observations must be taken for determining the average value of specific surface area of cement. The value of constant K can be determined by using a standard cement sample of known specific surface area and measuring the value of time t for a standard weight of cement which is normally taken as 2.8 grams. For the present case, the specific surface area of standard cement is given as 3400 centimeter square per gram and the time t is measured as 49 seconds. Therefore, the value of constant k can be determined as k is equal to 3400 divided by 49 under the root, which is equal to 486. This value of constant k shall remain same for the given apparatus and standard cement taken. For determining the weight of cement sample to be tested for its fineness, following steps are required to be carried out. Fill the cell with mercury up to the top. And level it with a small glass plate. Remove the mercury from the cell. And record the weight of mercury and dish as WA, which shall be 138.47 grams in this case. Measure 2.8 grams of the cement sample and place it in the cell. Place the filter paper disc on top . And insert the plunger till the plunger collar is in contact with the top of the cell. Remove the plunger and fill the space with mercury . Leveling it with the glass plate as before. Now remove the mercury from the cell . And again record the weight of mercury and dish as WB, which is 113.20 grams for the present case. The bulk volume occupied by cement is then calculated as V is equal to WA minus WB divided by D, where WA and WB are the weights of mercury as recorded earlier, and D is the density of mercury, which is 13.53 grams per cc at test temperature of 28 degrees centigrade. Therefore, volume V can be calculated as 138.47 minus 113.20 divided by 13.53, which shall be equal to 1.86 cc. For calculating the weight of cement sample required for the test, use the relation W is equal to rho multiplied by V multiplied by 1 minus E within brackets, where rho is the density of cement sample, which is 3.15 multiplied by 1 is equal to 3.15 grams per cc, where 3.15 is the specific gravity of cement sample. V is the bulk volume of cement and shall be equal to 1.86 cc as calculated previously. Small e is the required porosity of cement bed, which is 0.500 plus minus 0.005 for OPC and PPC, and 0.530 plus minus 0.005 for high early strength cement. For the present case, the weight of given ordinary Portland cement sample can be calculated as W is equal to 3.15 multiplied by 1.86 multiplied by 1 minus 0.500 within brackets, which shall be equal to 2.93 grams. Once the weight of cement is calculated, perform the experiment as described earlier and calculate the specific surface area using the equation S is equal to 486 multiplied by T under the root in centimeter square per gram, after noting down the time T in seconds. Blaine's air permeability test is important since it gives an idea of the size of smaller grains of the particles, which play a major role in the process of hydration and strength development of cement. Thank you very much.